Welcome, network architects. Today we are focusing on NVIDIA Spectrum networking, specifically zooming in on advanced quality of service and telemetry. These two pillars are what transforms standard Ethernet into a high-performance, lossless fabric capable of driving the world's largest AI clouds. Let's get started. Let us kick things off by defining our core focus. In standard enterprise networks, losing a few packets is acceptable. TCP simply retransmits them. But in AI, dropped packets mean idle GPUs, ruining your job completion time. To fix this, NVIDIA introduced the Spectrum X platform, combining Spectrum, 4 switches with BlueField, 3 super NICs. Advanced QoS acts as the active shield, managing massive AI elephant flows to completely prevent network congestion. Telemetry acts as the all-seeing eye, giving us microsecond-level visibility into exactly how data is moving. Together, they allow Ethernet to behave as a lossless fabric, achieving up to 95% effective bandwidth at hyperscale. Look at this high-level architecture. The AI workload flows through the BlueField, 3 super NIC, which applies strict QoS parameters before the data even hits the Spectrum 4 switch. Simultaneously, the switch streams detailed telemetry out to our visibility dashboards, creating a closed-loop system of control and monitoring. To make Ethernet lossless for AI, we use a technology called ROS, RDMA over Converged Ethernet. But ROS alone isn't enough. It requires advanced QoS mechanisms, specifically priority flow control, or PFC, and explicit congestion notification, or ECN. Think of PFC as a traffic cop with a stop sign. Before a switch's buffer completely overflows, it sends a PFC pause frame to the sender, temporarily halting traffic. ECN is a bit more graceful. As switch buffers begin to fill, the switch marks passing packets with an ECN bit. When the receiver gets this marked packet, it tells the sender to slow down its transmission rate, effectively smoothing out the traffic spike before a hard pause is ever needed. This sequence diagram shows the dual-layered defense of advanced QoS. When the sender pushes a massive data burst, the switch's buffer hits a threshold. It immediately fires a PFC pause frame backwards to stop the sender. Concurrently, it sends an ECN-marked packet forward, prompting the receiver to tell the sender to reduce its transmission speed. Moving deeper into QoS, we encounter the concept of performance isolation. This is absolutely critical if you are building a multi-tenant AI cloud. Imagine Tenant A launches a massive, poorly optimized training job that floods the network. Without isolation, this noisy neighbor will cause congestion that spreads across the fabric, destroying the performance of Tenant B's perfectly optimized job. We solve this using the Spectrum for switches fully shared packet buffer architecture. By configuring strict traffic classes and QoS profiles, we guarantee bandwidth SLAs per tenant. Because Spectrum uses a universally shared buffer rather than rigidly partitioned port buffers, it can dynamically allocate memory to absorb sudden microbursts on any specific port, ensuring the noisy neighbor is contained. Here we visualize performance isolation. Tenant A and Tenant B both send traffic into the Spectrum for shared buffer. Because they are assigned different traffic classes, the switch's QoS policy enforces strict isolation. Tenant B receives its guaranteed bandwidth and low latency, completely unaffected by Tenant A's heavy workload. Now we transition from QoS to telemetry. When building high-performance AI fabrics, traditional monitoring tools like SNMP are practically useless for real-time diagnostics. They poll too slowly. This is why NVIDIA developed What Just Happened, or WJH. WJH sits directly on the switch ASIC, inspecting packets at line rate. If a packet drops, standard tools just increment a drop counter. WJH, however, captures the packet header and tells you exactly why it dropped. Was it an ACL violation, a buffer overflow, or an L2 routing error? It packages this deep contextual data into a JSON payload and streams it out in real time. This transforms troubleshooting from blindly digging through logs into instant root cause analysis. Follow the packet's journey. It enters the switch and undergoes ASIC inspection. If valid, it forwards normally. But if an anomaly or drop occurs, the WJH engine instantly intercepts it, extracts the header and the specific drop reason, and outputs a highly detailed JSON telemetry stream for administrators. Having granular telemetry is fantastic, but how do you actually consume it? NVIDIA offers NetQ, a highly scalable network operations toolset that ingests WJH data and visualizes it across your entire fabric in a rich GUI. NetQ correlates configuration changes with operational status, allowing you to instantly pinpoint anomalies. However, flexibility is key. The telemetry is streamed from the switch using GNMI, the gRPC network management interface. It relies on standard OpenConfig Young data models. This means if your enterprise already relies on third-party tools like Splunk, Grafana, or your own custom dashboards, you can easily ingest WGH data directly without being forced to use a proprietary management server. This diagram maps the telemetry export paths. The WGH data originates on the Spectrum switch and is processed by the NetQ agent using the standard GNMI protocol. From there, the stream can diverge, feeding natively into the comprehensive NVIDIA NetQ GUI, or routing straight into your existing third-party analytics platforms. Let us look at a real-time use case. Imagine you are running a massive trillion-parameter LLM training job, and it suddenly experiences severe, intermittent latency spikes. You check your traditional SNMP dashboards, everything looks green. Bandwidth averages are fine, and there are 0 physical port down errors. What do? You open your NetQ dashboard and check the WGH events. Instantly, WGH flags hundreds of buffer tail drops. What happened? The AI workload generated massive, microburst traffic spikes that happen in a fraction of a millisecond, overflowing the buffer too fast for SNMP to ever see. Armed with this exact root cause, you adjust your ECN QoS thresholds using NVIDIA, the network smooths out, and your AI training job stabilizes. This flow highlights the difference between legacy and modern troubleshooting. While SNMP completely misses the microburst, WGH telemetry instantly detects the specific buffer tail drops. We take that actionable insight, tune our QoS profile via NVIDIA, and stabilize our critical AI workloads. We conclude with practical implementation. To deploy these advanced features, we use NVIDIA's declarative, schema-driven command line and API. Enabling our telemetry engine is as simple as running NVSet system WGH enable on. To lay the foundation for our lossless AI fabric, we apply our QoS profiles using commands like NVSet QoS ROS enable on. By managing these parameters through NVIDIA, you ensure consistent, error-free configurations across your entire data center. To summarize, mastering Spectrum networking requires understanding how perfectly tuned QoS and real-time WGH telemetry work together to keep AI GPUs constantly fed. Thank you for joining this session. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. This final diagram breaks down our Spectrum AI fabric blueprint. Success relies equally on configuring advanced QoS with PFC, ECN, and shared buffer isolation and deploying WGH telemetry for ASIC-level drop analysis and NetQ visibility. Master these, and you master the AI data center.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.